Hi, my name is Clint Wyckoff and I'm a Principal Tech Marketing Engineer with Nebulon. Nebulon is a pioneer of cloud-defined storage, a cloud-managed, server-based storage platform built for application owners. Cloud-defined storage allows app owners to consume and automate infrastructure when and where it's needed. In this product demonstration, I will show you how to install the Nebulon CSI driver for Kubernetes, as well as some basic functionality. For this demonstration, I utilized an Ansible playbook to pre-create a 4-node Kubernetes cluster and necessary dependencies running on Ubuntu 1.8.04 and pre-created a 4-node Nebulon npod. For more information about Nebulon, as well as other demo videos, please be sure to check out our YouTube library. As we can see within Nebulon On, our cloud-based control plane, I have utilized my Kubernetes application template and no storage volumes were provisioned with the npod creation. The Nebulon CSI driver will handle the creation and management of the required volumes whenever we apply our kubectl configuration. As we switch over to our terminal, we can see that I have created a 4-node Kubernetes cluster and I have SSH'd into server 1, which holds the Kubernetes master role. Secondly, we can quickly see that this is a vanilla Kubernetes cluster with the Metal LB load balancer in which I have deployed within my Ansible playbook. Next, I will install the Nebulon CSI driver for Kubernetes. The CSI driver is able to be obtained from the Nebulon GitHub repository and is done via a Helm chart. I will add my repository, search the repository, and lastly, install the driver utilizing the Helm install command. We can quickly see that the CSI-Nebulon has been installed and is now running in the default namespace. For the purposes of this demonstration, I will be deploying a simple single-node WordPress example. I have already cloned the WordPress example locally and apply the configuration to my Kubernetes cluster. If we take a look at the WordPress-deployment.yaml file, we can see that I have specified necessary details surrounding my persistent volume claims. To validate this, I will reload volumes from my npod within Nebulon On and pull in my terminal, and then run get pvc on the WordPress namespace to list out the PVCs related to my site. Volume ending in Foxtrot 6 Echo 1 lines up to my WordPress PV claim and is visible within Nebulon On. This is denoted with the red annotation. Volume ending in 9613 denoted in yellow aligns to the MySQL database for my WordPress environment. Let's quickly take a moment to gather the external IP address for my WordPress blog and configure. Then we'll write our very first blog post. In the top terminal, let's toss in a watch of our WordPress pods. We can see our WordPress web server is running on server 3. Before we initiate failure, let's cross-compare the WordPress site to Nebulon On and validate that the PVC is running on server 3 as well, which it is. Now let's initiate a cordon of server 3, which is the pod running my WordPress server portion of the WordPress site. If you're unfamiliar with the term cordon, this command prevents new pods from coming online on the node. Now let's delete all the pods in the WordPress namespace where the tier equals front end, keeping our eye on the watch terminal. We'll see our pod termination as well as the pod creation on server 4. When we quickly refresh Nebulon On, we can see that our PVC in fact has relocated from server 3 to server 4 automatically. To recap, we've deployed the Nebulon CSI driver for Kubernetes as well as walked through a pod failure scenario where we watched the persistent volume claim move from one server to another within our Kubernetes cluster automatically via the Nebulon CSI driver for Kubernetes. For more demo videos, be sure to subscribe to our YouTube channel and head over to nebulon.com. Thanks, and we'll see you next time.